Welcome to the second week of our Calculus 2 class. Today, in the pre-class video, we will be talking about importance of distinguishing between derivatives and antiderivatives. We're learning new tools of integration, and one of the very useful tools that we will meet this week is going to be integration by parts. And it's relying on students identifying right functions and then calculating, when appropriate, derivative or an antiderivative. It is very rare to have a simple question of integration where all we need is just the basic form. So let's look at the more typical examples that require paying attention to what exactly we're trying to find and which rules are applicable. Find derivative and antiderivative of a given function. Let's consider function f of x equals to 1 divided by 2x. The calculation of the derivative of this function requires either using a quotient rule or observing that a function 1 over 2x can be also written as constant 1 over 2 multiplied by x to the power minus 1. If we rewrite a function as a constant times a power function, we can calculate the derivative as 1 over 2 times derivative of x to some power n equals to n minus 1, in this case, times x to the power 1 less than before. So we will get minus 1 over 2 times x to the power minus 2 equal to minus 1 over 2x squared. When we're looking for an antiderivative of a function, we are trying to integrate 1 over 2x with respect to x. Here we can view, again, function 1 over 2x as 1 over 2 times 1 over x dx. And using constant multiple rule, all we need to do is find antiderivative for 1 over x and then multiply result by 1 over 2. Antiderivative for 1 over x is natural logarithm of absolute value of x plus c. Now let's do similar exercise to part A. Let's consider function f of x equals 3 sine of 1 over 9x, and let's find derivative and antiderivative of a given function. The derivative of 3 sine of 1 over 9x will require using a constant multiple rule, differentiating sine of 1 over 9x, using chain rule and trigonometric function rule. Derivative of sine is equal cosine, and because the argument of the cosine is not just x but a function of x, we have to multiply by the derivative of the argument of the function. Derivative of 1 over 9x is just 1 over 9. Therefore, the derivative of function f of x is equal to 1 over 3 cosine of 1 over 9x. Let's find an antiderivative of the function f of x. We need to integrate our original function. And here we have a couple of options. Option number 1. Instead of argument 1 over 9x, we can do u substitution and let u be equal to 1 over 9x. This means that the derivative of u with respect of x is equal to 1 over 9. So differential du will be replacing 1 over 9 dx, or differential dx is equal to 9 du. Using constant multiple rule, we will need to integrate sine of u, and instead of dx, we will write 9 du. We'll get 27 integral of sine of u du. This is basic trigonometric integral, and antiderivative for sine of u is a negative cosine. As soon as we go back to the original variable, we are done with integration. Method number 2 is also very common and useful. It's called guess and check. Using guess and check, we'll guess what antiderivative might look like, check how close we are to the actual function by taking derivative of our guess. Because original function has sine in it, I'm going to guess that antiderivative has cosine involved in it of the same argument. So I would guess that antiderivative of our function is equal to cosine of 1 over 9x. Now let's check if derivative of the function is equal to 3 sine of 1 over 9x. If I'll take a derivative of cosine, it's equal to negative sine over same argument. And because argument is not just x, I need to use chain rule and multiply by the derivative of an argument, which is 1 over 9. So the derivative of my guess is negative 1 over 9 sine of 1 over 9x. Was my guess a good one? Well, negative 1 over 9 sine of 1 over 9x is not equal to the original function given to us. Therefore, while part of the guess was good, I got the right trigonometric function with the right argument, the constants are not the same. Instead of minus 1 over 9 that I got, I needed to get a 3. So minus 1 over 9 needs to be multiplied by a constant such that the result at the end of the calculation would be equal to 3. Let's solve for this constant k. This should be equal to minus 27. I think antiderivative should be minus 27 cosine of 1 over 9x. Now that I corrected guess, I can check to confirm derivative of our function f of x should be equal to the original function f of x. If I'll differentiate, it's minus 27. Derivative of cosine is negative sine over same argument. And because argument is not just x, we need to multiply by the derivative of an argument using chain rule. We'll get 1 over 9. Minus 27 divided by 9 is negative 3. But there is also negative sign, which turns negative into the plus. Sine of 1 over 9. Yes, this is exactly original function. So we found a correct antiderivative. Don't forget the plus c, and we're done.